This is Algebra 2 with trig, 2b.4, composition of polynomials. The composition of a function g with a function f is g of f of x. We're very familiar with g of x, or we're familiar with g of 2. That's when you plug a 2 into your g function. But this is g of f of x. So that's when we plug the f function into the g function. So notice here, this is f of g of x. So we're going to start with the f function. The f function is 6 times something plus 2. The f function, that's the letter on the outside. 6 times something, 6 times x, plus 2. Then what's inside your f function is supposed to be g of x, not just x. So we're going to plug the g of x function into the f function. So we're going to say 6 times 3x plus 5 plus 2. I've written it twice just to show you that this is your first thought. This is your second thought, where you plug in the 3x plus 5 into the 6 times something plus 2. Then we distribute and add the like terms together.
Would it be 6x?
So notice that f of g of x is not the f function times the g function. We didn't FOIL anything together. We plugged the g function into the f function. Let's come on over and do g of f of x. So we're going to start with the g function, which is 3 times something plus 5. So we're going to plug the f function into the g function. 6x plus 2 gets plugged into the g function. We distribute, we get 18x plus 6 plus 5. Collect your like terms. Notice what's different here. Notice that f of g of x gave us this result, and g of f of x gave us that result. They're not the same thing. It's not multiplication. It's plugging one function into a different function. Okay, here we have f of x. So we're going to take our f function, which is 6 times something plus 2, and we're going to plug our f function into that. So it's 6 times 6x plus 2, then plus 2. Notice what goes inside the parentheses. Then we distribute. That's 36x plus 12 plus the 2, and then you can collect your like terms. Now to evaluate. You've done evaluates before. That's when we do g of 4, f of 3. That's to evaluate. But this is g of 4. So you've got two choices of how to do this. You can figure out what g of x is. So that would be your g function and plug your g function into it. So that's 9x plus 20. Then you're going to plug 4 into the x. That would be 9 times 4 plus 20. 36 plus 20. That's 56. So g of 4 is 56. That's one method. Figure out what g of x is, and then plug the 4 in. The other method that you can do, or you could figure out what g of 4 is. G of 4 is 3 times 4 plus 5. That's 12 plus 5, which is 17. Then we're going to plug the 17, the g of 4, into the g function. So now we're going to do g of 17, which is 3 times 17 plus 5. That's 51 plus 5. Look at that. It's the same result. Either method works. You probably like this. This seems a little bit smoother to me. But either method works. Sometimes in previous problems, we've already calculated what g of x is. Like here, if we would have done it to this problem, we could take it from a previous problem and then plug your numbers in. That could be faster. But if you have to do it from scratch, you're welcome to figure out the g of 4 and then plug that result back into the g function. Or figure out g of x and then plug the 4 into that. Down to our word problem. You purchase water skis at a price tag of $180. The sports store applies a newspaper coupon of $50. And a 10% store discount to your prices also. Use the composition to find the final price of a purchase when the coupon is applied before the discount. Coupon applied before the discount. So you have a discount and you have a coupon. And the coupon's going to affect your price first. What is your price? Affect that, and then do your discount. So, you have your $180. You're going to do your coupon first. Your coupon is a $50, so we're taking $50 off. That's the coupon. So now the price is $130. Then we're going to apply the 10% discount. Everybody in here should know what a 10% discount off of $130 is. You move the decimal spot 1 to the left. That's 10%. $13. So we're going to subtract $13, which is a 10% discount, which is going to give us $117. So the total price is $117. Now we're going to do it in the other direction. Use the composition to find the price of a purchase when the discount is applied before the coupon. We're going to take the coupon and we're going to apply the discount to it beforehand. So we take our 180 and the discount was the 10%. So by moving the decimal spot over 1, in this case we're subtracting 18. So that's 162. That is a 10% discount. And then we subtract the 50, which is your coupon. So you see that order matters. Can you give an explanation on why it was cheaper in this case than it was over here? We took 10% of a larger number. You always want to take the percentage off of a larger number. 10% of a bigger number is more money off. The 50 is always off. Doesn't matter. So you want that to be off of a smaller amount. So we took 10% off in this situation and only discounted ourselves $13. In this case, we discounted ourselves $18, and that was the difference between the two prices. All right, these are just more practice problems. These can be a little bit tricky ones, but they're just practice problems. So let's pause the video. You go ahead and try letter A, maybe even the rest of them, then come back and we'll talk you through. F of g of x. We take the f function. F function is 5x minus 4. So we're 5 times something minus 4. The x is just a parenthesis, and we're going to plug in the g of x into that parenthesis. So we're 5 times x cubed minus 4. Because the x cubed is the g of x, and the g of x gets plugged into the f for every x value. So this becomes 5x cubed minus 4. This is g of f of x. So we go to our g function, which is x value, which is something being cubed. You're going to plug the f function into that. 5x minus 4 cubed. Now, depending on how you want to calculate this, you could write the parenthesis 3 times, and then FOIL it, and then double distribute. That would totally work. You could also use the binomial theorem like we've learned in the past. I'll practice with that. That's 1, 3, 3, 1. That's putting your a term before it and cubing it, your a term and squaring it, your a term to the first power, and your a term to the 0 power. You don't even need to write that. Then you have the negative 4 to the 0 power, negative 4 to the first power, negative 4 to the second power, and definitely negative 4 to the third power, with a plus in between each one. So this is going to be 125x cubed. This is just 1 times 1. Plus 3 times 25x times negative 4. Plus 3 times 5x times 16. Plus a negative 64. Well, nothing can be done with the 125. This would be 12, so negative 12 times 25. That's 300. This is 15 times 16. Well, 15 times 15 is 225. 225, 235, 240. So this is going to come out to be 240. this would have to be 25x squared, so that makes this a square. And then minus 64. Notice my signs are plus, minus, so that makes sense. My exponents are decreasing. So there you go. That is g of f of x. You go ahead and try f of h of x. And if you want to come over and then try h of f of x, try your next two. Pause the video and give it a try. So the f function, that's this guy right there. The f function is 5 times something minus 4. The something is going to be inside the f function. The h is going to go inside the f function. So to do that, we need to distribute and then collect our like terms. And that is f of h of x. Now we have h of f of x. So we take our h function. There's our h function. Notice we have x in two different spots. When we write it out the first time, our h function, it is something being squared minus 2 times something plus 7. So we're going to plug our f function into that. So that's our 5x minus 4 that's being squared minus 2 times 5x minus 4 plus 7. Now, for you to be able to multiply this, to square this binomial, remember you have to write it twice. 5x minus 4 and 5x minus 4. That's going to give us 25x squared. You get a 20 and a 20, which is negative 40x, and a positive 16. Then you're going to distribute to get negative 10x and positive 8, plus your additional 7. So our final result is 25x squared. The 40 and the 10 gives us 50. Here we have 16 and 15, which is 31. Now to evaluate, this is g of f of 2. Well, g of f, we already did that up here. G of f. So we've already calculated out what that was. So g of f of x, we already know that that is 125x cubed minus 300x squared plus 240x minus 64. If we want to figure out what g of f of 2 is, one way we could do it would be to plug a 2 in for all the x's. Now, if you remember back, we learned another method. That's called direct substitution. We learned a method called synthetic substitution. That's when we take our 2 and we take the coefficients of 125, negative 300, 240, minus 64, and we can use synthetic to have us calculate this out. Drop down your 125, multiply to get 250, add these two together, multiply, and multiply. That gives us 216. So that's one way for us to do this. The other way for us to do it is to figure out what is f of 2. Plug 2 into the f function. So that's 5 times 2 minus 4. That's 10 minus 4, which is 6. And then plug the 6 into the g function. So that's 6 cubed, which is 216. It works both ways. Your choice. This seems pretty good, but wasn't too bad because we already figured out what g of f of x was. Here we have f of h of 1. So if we can figure out what f of h is, we've already calculated that. So we don't need to recalculate it. We've already done it. That is 5x squared minus 10x plus 31. Now we're going to plug a 1 into it. We could use synthetic if you like. That'll work out really smooth. Or you could just do it the long way, and 5 times 1 squared minus 10 times 1 plus 31. The trouble here is that a lot of people are going to call that 5 times 1 squared is 25. This is not 25. This is 1 squared, because the square is only affecting the parentheses. So square the 1 times 5 minus 10 plus 31. That's negative 5. So that is 26. Or you could figure out h of 1. So your h function would have been 1 squared minus 2 times 1 plus 7, which is 6. And then your f function was 5 times 6 minus 4, which is 30 minus 4, which is 26. This is the same thing we had before. And we've already answered this question a few times. Is f of g of x and g of f of x the same thing? Can you switch it? That's what this means. Commutative property. And we know that to be no, it isn't. Because here is f of h of x and here is h of f of x. And we got two different results. Okay, no, these are not always the same. It might be possible that it would be the same, but these are not always the same. We gave you many examples where they were not the same.